Okay, first problem. Y equals the natural log of the square root of x. And this is a little bit different than what we did on the first day. The first day we were pretty much going exponential form to logarithmic form, back and forth. This one we're actually finding the derivative. Okay. Okay, check your answers. And there's more than one way to write this. You can say that the square root of x is x to the 1/2 power. Remember the logarithm of derivative, I should say. If I said y equals, if it was just natural log of x, and I took the first derivative would be 1 over x. If I did y equals the natural log of u, where u is some quantity, okay, some differentiable function, then this would be 1 over u times the derivative of u with respect to x. So this x to the 1/2 power, okay, the derivative of this is 1 over that. You could write that as radical x, okay, times the derivative of x to the 1/2 power. So that'd be 1/2 x. Depress that exponent by 1, be to the negative 1/2. And then you can simplify it down to 1 over 2x. You should get all the way down to that answer. Okay? To get rid of this, if I move that down, if I simplify, I can do it more than one way. If I do it in exponential form, okay, and then if I move this down and make it a positive exponent, now when I multiply those, add the exponents, I'd be at x to the first. I could also write it like this. I could have it okay. Yep. Do you understand the process? Everybody okay with the process? Okay. Next problem. Y equals the natural log of e to the x divided by 2. That e to the x divided by 2 is like your u. Okay, that's like the u. Okay, let's check answers on that one. Okay. So the derivative of the natural log of e to the x over 2 is still 1 over the e to the x over 2. Then you have to take the derivative. Basically, you're taking, it'd be like saying g of x equals e to the x over 2, or you could write it 1/2 e to the x over 2. Okay, the 1/2 stays the same. What's the derivative of e to the x? E to the x. If I said y equals e to the x, derivative of e to the x is e to the x. If I said y equals e to the 5x, derivative of that is e to the 5x times the derivative of that exponent. So it'd be 5e to the 5x. Okay. Okay, then on this you just simplify that out. Okay, and you end up with 1. Okay. Okay. Can you check that on the calculator? Can you? Put this in y sub 1. In y sub 2, what did we used to put in there to find the derivative? The numerical derivative of y sub 1 comma x. And then put your answer in y sub 3, and they better check. Okay, take a minute and try it. Okay, let's try another one. Okay, y equals the natural log of the quantity 3x squared plus 6. Still using that same formula on your card. Okay, same idea. It's 1 over that quantity, and then it's times the derivative of that quantity. So derivative of that would be 6x and then plus 0. Put the 6x on top. They factor out a 3. Okay, they should get all the way down to 2x over the quantity x squared plus 2. Okay? Okay with that one? Okay, y equals e to the 1 plus natural log of x power. On this one, you should be looking at this on your card. Y equals e to the u power. Y prime is e to the u power times the derivative of u with respect to x. Do you have that on your card? Should have. Check. Do we need to add that one? Okay, let's stop for a minute and add that one. Okay, check answers on this one. Should end up with the first derivative is the e to the 1 plus natural log of x, and then the derivative of 1 would just be 0, and the derivative of natural log of x is 1 over x. You could write it like this or write it all together. Okay. What? Okay. Y equals the natural log of 3x. Okay, check answers. Should end up with 1 over the 3x times 3. The 3's divide out. Okay? And you end up with 1 over x. Okay? Everybody okay on that one? Okay. Y equals e to the 6x power. Find the answers. Okay. Derivative of the e to the 6x would be just e to the 6x. Then it's times the derivative of that exponent. And they will probably put this coefficient out in front. So it should be 6e to the 6x power. And this is the formula that you're using. Is that what we just added a minute ago? Okay. Okay. Okay, on this one, y equals x squared. Now, the critical part of that is that little dot times e to the negative x. Which rule? Times means product. Product rule. Remember, they're going to throw back in product rule, quotient rule, chain rule. Okay, so you can't ignore that little sign. Now take the derivative, product rule. Okay, so here's product rule. Leave the first one the same, so that's the x squared. Times the derivative of e to the negative x. That's e to the negative x. Then times the derivative of that exponent would be a negative 1. Then product rule says plus. Leave the second one the same, so that's e to the negative x times the derivative of x squared is 2x. They will move this negative 1 out front, so you end up with negative x squared e to the negative x plus, and then they will probably move the 2x out front, 2x e to the negative x. So I would star that product rule. Okay, so you got to remember the product rule. That goes Do you kind of understand way back when I kind of drilled that into your brains? Yeah, there was a reason for that. Okay. Okay, let's try another one. Y equals 5x minus e to the 4x power, that quantity cubed. Which rule? Chain rule. Yep, chain rule. Okay, take a minute. Okay, on this one on chain rule, you take this exponent times the number in front, so that 3 just goes out front. The part inside the parentheses stays the same. You depress that exponent by 1, so it goes to a squared. Then it's times the derivative of what's inside. So the derivative of 5x is just 5. And the derivative of e to the 4x is e to the 4x, then times the derivative of the 4x, which is 4. And they'll put that 4 in front. And you could move this in front, this quantity in front, but you don't have to. Okay? And that's as far as I would go on simplifying that. Okay? So that one is star it. That one is the chain rule. Okay? Okay, y equals x squared plus 5x, and it's all over e to the x. Which rule? Quotient rule. We've done product rule, chain rule, quotient rule. What do you have to start with? You have to start with the denominator times the derivative of the numerator minus okay, check your answer. So you start with the denominator, e to the x, times the derivative of the numerator, so that'd be 2x plus 5, minus, leave the numerator the same, times the derivative of the denominator. Remember, the derivative of e to the x is e to the x. And then it's all over that denominator squared. Okay? And notice that minus sign applies to everything. So you want a grouping symbol around that. Okay? Okay, switch gears now. We've been doing derivatives. Now we're doing integration. Okay, evaluate. You should have some formulas on your card. Evaluate the integral, indefinite integral. If it's indefinite, what's it going to have on the answer? A plus c. Evaluate the indefinite integral of e to the 4x power with respect to x. Okay, check your answer. If you do it like integration by substitution, you can let the u be 4x. Okay? Then the derivative would be 4 with respect to x. You need to be able to substitute in for everything. So you need to be able to substitute in for this would give you the e to the u, but you also have to substitute in for the dx. So you want to get the dx by itself. So multiply by 1/4. Okay? Should get 1/4 e to the 4x power plus c. Okay. Okay. Okay, here we go. Next one. Okay, solve the log of 4x plus 10, that quantity to the base 2, minus the log of x plus 1 to the base 2 equals 3. If you're subtracting the logarithms, what were you doing with the numbers? Dividing them. And then what we're solving for is x. What's x equal? Okay, on this one, if you divide if you subtract the logarithms, you were dividing the numbers. So divide the 4x plus 10 divided by x plus 1. Now you're in logarithmic form to solve it. And a lot of that, if you're stuck in logarithmic form, go to exponential. If you're in exponential, go to logarithmic. So on this one, your base is 2, The exponent is 3, because remember logarithm is just an exponent, equals the 4x plus 10 over x plus 1. You can do a proportion cross multiply, okay, multiply by x plus 1 on both sides. Should end up with x equals 1/2 for your final answer. Okay. Yep. Okay, y equals the square root of x times the quantity x plus 1. Use logarithmic differentiation to find the derivative. And you have more than one example in your notes and problems to look at. On this, you'd say that whole thing's underneath the radicals, so it's all to the 1/2 power. First step then, you're going to take the natural log of both sides. So you just write ln on both sides. Third law of logarithms, that 1/2 goes out front. Okay, and then you're multiplying these two quantities, so you add their logarithms. The 1/2 can stay out front. So you split this up and add their logarithms. Okay, then you start taking the derivative. So take the derivative of the left side. The derivative of natural log of y is 1 over y times the derivative of y with respect to x. And you're also using the implicit, that's why you have that extra dy over dx. Derivative of natural log of x is just 1 over x. Derivative of natural log of x plus 1 is 1 over x plus 1. Then it's times the derivative of each one of these. Derivative of x is 1, derivative of 1 is 0. So you don't have to show that 1 there. You don't have to have this there. I'm just showing it so you remember you have to take the derivative of whatever's inside. Okay, and then multiply by y on both sides, and then you got to go all the way back up here and say what's y, sub that in. Okay, and that's your final answer. Maybe not. Got one more. Last problem. The log of 5x plus 3 base 8 equals the log of 45 minus 2x base 8. Solve for x. Okay, check answers.